So we know that we start with 60 revolutions per minute. We want to cancel the revolutions, and this is the numerator, this is the denominator. That's excellent. So we can go ahead and put that in there and multiply. We can cancel the revolutions and the revolutions. And then we have feet. Now we've got our feet. Now we need to change the minutes to seconds. As before, to change the minutes to seconds, we use 1 minute is equal to 60 seconds. And we can cancel the minutes. And in this case, we can also cancel the 60s. And now we have 3 pi feet per second. Okay. We like our answers like this, but sometimes we can convert that or multiply that out and get 3 times pi, which is 3 times 3.14, which is 9 point something. Right. Let's try a second problem. It's very similar to the first one. I just changed some of the numbers. See if you can work through this on your own. And when you're ready, unpause it and check your work. Okay. A wheel has a diameter of 8 centimeters and rotates at 450 revolutions per minute. Find the angular speed in radians per second. So we're going to look at what's given, which is 450 revolutions per minute. Diameter is 60 centimeters, and we're trying to find the radians per second. We need to change the revolutions to radians and minutes to seconds. So we know that 1 revolution is the same as 2 pi radians, and we're going to leave the radians in the denominator, so we can cancel the radians in the numerator here with our problem. So multiply that by 2 pi radians over 1 revolution, cancel the revolutions. Now we need to convert the minutes to seconds, so that's 1 minute per 60 seconds. Cancel the minutes. And we can reduce the 450 by 60, and I can take off a 0 there, and we can also divide both of these by 3, and I get 15 and 2. Reducing the 2's here, we can get that, and I think we're all cleaned up. We have radians per second, and that'll be 15 pi radians per second. Okay, we normally leave, especially in Trig, we like to leave our pi as in the answer because we want the exact answer. This is the exact answer. If you put in 3.14, that means you rounded the pi. You're going to get a rounded answer here. Let's do part B. Remember to try it on your own before you look at the video. Okay, here we go. Find the linear speed in meters per second. So we start with a given, and then we're trying to find meters per second. We need revolutions per 2 meters, not feet here. They should say meters. And we need to change the minutes to seconds. We know that 1 full circle around the outside is the circumference, and that's equal to the diameter times pi. So we can say that the circumference, 1 full around on the outside, is 8 pi centimeters per revolution. So we have 450 revolutions per minute times 8 pi revolutions centimeters per revolution. Cancel my revolutions. And we also need to change the minutes to seconds and cancel my minutes, reduce and we'll also have to change our centimeters to meters. So we know that there's 1 meter is the same thing as 1 centimeter, right? Cent. How many cents are there in a dollar? There are 100 cents in a dollar, so there are 100 centimeters in 1 meter. Okay, 100 centimeters in 1 meter. So now we can reduce the centimeters, and we end up with meters per second. Clean this all up with, you can reduce, or you can just use your calculator. 450 times 8 divided by 60 divided by 100, and you get approximately 1.88 meters per second using the pi. Don't forget the pi. Okay, so you're going to do this and leave your answer with the pi in the answer instead of giving me the rounded decimal answer. So you have a wheel of 10 centimeters and rotates at 50 revolutions per minute. Find the radians per second and the meters per second. When you're done, we'll continue our lesson. Central angle. The central angle is an angle that has a vertex at the center of the circle. That's all that is. And the intercepted arc is the piece of the arc cut off by the angle, the central angle. So the whole outside, the circumference, is the whole circle, and that piece of that circle is called an arc. So the intercepted arc is the part of the arc that's cut off by our angle. There's our radius, in case you forgot. Okay, this is the formula you're going to need, and I don't like to memorize a whole lot of things, so I don't memorize this. I just recreate it in my mind when I need it. And how this makes sense is that this is the circumference, or basically the whole circle. This is 2 pi r, right? 2 times r is the diameter. Diameter times pi is the circumference. This is the whole circle on the outside, and 360 degrees is the whole angle on the inside. And the S is the intercepted arc, so this is the piece of the circumference, and the angle is the piece of the whole circle, the 360. Or if the angle is in radians, then we will use 2 pi. If the angle is in degrees, we use the 360. That's why there's an or here. We either use this one or this one, depending what the units are on the angle. If the given angle is in degrees, use 360 in the denominator. If the angle is in radians, then use the 2 pi. Okay? You understand the formula? Okay, so this is the whole, part. This is the outside, and this is the inside, or this is the length of the outside, and this is the angle. Okay, whole, part. Okay, there's the circumference.